So now that we know the difference between a linear and a nonlinear function, let's start with graphing linear functions. To graph a linear function, let's take a simple one such as y equals 2x minus 3. And we're going to graph this linear function. We're going to attempt to graph this on the coordinate plane using an xy axis, the origin, and the quadrants, namely quadrant 1, 2, 3, and 4. So to graph a linear function, what we want to do is we're going to graph this using a table of values. So we're going to use an x and a y. Now, we're going to use at least 3 points to graph this line. We know it's linear first of all because it has an x in it, and x is to the first power. So what we're going to do is we're going to pick some numbers to put in for x, numbers that would be easy to find the y value. So we're going to start with, let's go ahead and start with 0 for x. Now if I start with 0 for x, I'm going to take 2 times 0, and my x in this case is 0, minus 3. Now that's going to give me a y value of 2 times 0, which is 0, minus 3, or negative 3. Therefore, I have the point 0, negative 3. And I'm going to go over to my graph, and I'm going to go and plot that. Now next I'm going to go and pick another number for x for the domain. I'm going to go and pick it 1 this time. So that's going to give me 2. And for x, I'm going to put in 1, minus 3. This is 2 times 1, which is 2, minus 3, or negative 1. And so I have the point 1, negative 1. And once again, I'm going to go over to my graph, and I'm going to plot 1, negative 1. Now it's a linear function, so right now 2 points are needed to make a line. But to make sure I've done things right, I'm going to go and put in 2 for x. So this is going to be 2 times 2 minus 3, which is 2 times 2 is 4, minus 3 is 1. And I have the point 2, comma 1. So that would be 2 to the right and 1 up. Notice all of my points fall into a line, and so this is a continuous domain. So I'm going to get a line that looks something like that. Now, not all linear functions may be as easy to graph as that one. So we're going to try a little bit different one. We're going to try y equals 1/3 x plus 1 this time. And we're going to go ahead and try to graph that one. Okay, so I need some numbers for my domain. So I'm going to start with the old trusty x equals 0. So if I do that, I'm going to have 1/3 times 0 plus 1. Well, 1/3 of 0 is, well, 0 plus 1, which is 1. So I have the point 0, comma 1. Now notice that 0, comma 1, and in the previous one 0, negative 3, those were kind of my starting places every time. So if I want to tell the difference between graphs, I can plug in 0 for x and see what the y value is from that. Okay, well, I kind of want to avoid fractions if I could, so instead of putting in 1, because my y value might be a little harder to graph, I'm going to try to get numbers that are, well, whole numbers or integers. So I know 1/3 of 3 is pretty easy to work with, so I'm going to use 3 for my next x value. So that's going to give me 1/3 of 3 plus 1. Well, 1/3 of 3 is 1, and 1 plus 1 is, well, the trusty 2, so I end up with the point 3, comma 2. And I'll go over and start from my origin and go to the right 3 and up 2 and get a second point. So I see my line starting to form. Well, I also know 1/3 of 6, but, well, 6 is going to be a little bit too far in my graph, so what I'm going to do is I'm going to pick, well, a negative number to use this time. Like, I'm going to use negative 3. If I use negative 3, that's going to be 1/3 of negative 3 plus 1. And I know a third of negative 3 is negative 1, and negative 1 plus 1 is 0. So I have the point negative 3 comma 0. So left 3 and don't have to go up or down any. So if I connect the dots, I get a line that takes on that shape right there. Still a line, has a different rate of change or a different slope. So that's how I really can graph linear functions. And so if you take a look at the linear functions, yes, they are indeed lines. So how do I distinguish between, well, other graphs? Well, I want to give you a little information about that. If you see a y equals x squared graph, that's going to be a parabola shape, either going up or could be even going down. It's a squared. It has two different directions to it. It goes up and down, or down and up. Where a linear equation lays one direction, either goes up or down, or I guess could go horizontally. Now, y equals x cubed has three different directions to it. It could go up, down, and come back up again. And you'll learn later why it has three different directions. It also could go down and come back up, and then go back down again. So how would we plot something like this? Well, let's try a couple examples here. Let's say we wanted to graph y equals x squared minus 3. Well, a good way to graph this is plug numbers in again for x and see what we get for y. So we're going to start with 0 for x. And so if I put in 0, that'll be 0 squared, that's 0, minus 3 is negative 3. Now, next I'm going to put in 1. If I put in 1, that's going to be 1 squared, which is 1, minus 3 is negative 2. Now, I'm going to go ahead and put in 2, and 2 squared is 4, and 4 minus 3 is 1, and so you see there's not a linear pattern here because the difference in each y value is not consistent. So if I were to go ahead and begin to graph this, well, I have 0, negative 3, I have 1, negative 2, and I have 2, 1. And so what I've started to develop is I've started to develop a shape like this. Now, x squared equations have some symmetry to them. What happens on the right is also going to happen on the left. Now, I can verify this side over here by also plugging more points in, like, well, I could make another table and put in negative 1. And negative 1 plugged in would give me negative 1 squared minus 3 is, well, negative 2, which is this point down here. And if I put in negative 2, I get negative 2 squared, which is 4. And 4 minus 3 is 1, so I get this point over here. And it verifies that it's a U or a parabola shape, as we call it as well. Now we can also determine an x cubed equation doing the same way, plotting points. So if I were to look at y equals x cubed minus 1, if I depict just one point on this graph, well, 0 for x. If I put 0 in for x, I'm going to get negative 1 for y. So I know that x cubed minus 1 is going to have the point 0, negative 1 on it. Now what does the rest of it do? It depends on what other points I choose. And no matter what points I pick, I'm going to get the same shape. It's just I can choose whatever points I'd like to graph this nonlinear function. As you move on mathematically, you'll understand and start to understand more concepts and parts of functions that aren't linear. But for now, graphing linear functions, make a table, you will see the lines form. Graphing things that aren't linear are going to take the form of, well, x squareds or x cubes, or, you know what, there's way more than that too. There are also y equals absolute value equations, which take on a v-shaped form. And there are y equals the square root of x functions, which take on a form that looks like so. So graphing nonlinear functions, there's a lot more to it than that, but for now you can go and make a table and you can go and figure it out from there. Notice all of these domains that we've looked at in the table are continuous, which means we can use everything on an interval. Discrete domains mean we can only use certain points along the way as well.